Today we'll be talking about linear measure, which is the distance between points of a line segment, and we'll be talking about midpoints. Before we talk about linear measure, we need to know what a line segment is. A line segment is a part of a line that has a starting point and an ending point. Below, I have drawn a line segment AB, but there is a proper way to naming this line segment. The proper notation is line segment AB, because our segment starts at A and goes to B. Or we can say line segment BA, where it starts at B and ends at A. I have included another example that has a line segment with multiple points on the segment. Here, we still have to understand to name this segment properly. We have to start with the starting point and end with the ending point. We can name this line segment AD, where it starts at A and ends at D, or line segment DA, where it starts at D and ends at A. Now we know what a line segment is, now we can talk about linear measure. Linear measure is the distance or the length of that line segment. Just remember, distance is always measured in positive units. Below we have an example to give us a better understanding of how we can use distance or length to help us solve for variables or linear measures. In the example, the information given is that point H is between F and S on the segment FS, where FS is 24, FH is 3x minus 4, and HS is 2x plus 3. To get a better understanding, let's draw a diagram together. And as you can see through the diagram, H is between F and S, where FS is 24, FH is represented by the expression 3x minus 4, and HS is represented by 2x plus 3. In order to solve for x, we need to come up with an equation. We do know that FH is a part of this whole segment, along with HS is a part of this whole segment. Well, we need to come up with that equation. The one thing we do know is that FH plus HS is equal to 24. We now can use our algebra skills and solve for the missing variable. After doing our algebra and combining like terms and working backwards, we find out that x equals 5. Now, using our understanding of linear measure, we can now talk about congruent segments. Congruent segments are segments with the same exact measure. And below, I have included two line segments, segments AB and segments CD. The questions we need to ask ourselves is, are these segments the same exact measure? As you can see, these segments have these tick marks on these lines, and these tick marks represent that AB and CD have the same exact measure. Well, if we know they have the same exact measure, we can write a congruent statement. Line segment AB is congruent to line segment CD. The big information here is that we included our notation for congruent. When we put this all together, this is what we call a congruent statement. After speaking about congruence, we can now talk about midpoints. The midpoint is the middle point of a segment. It divides that segment into two equal parts, and the midpoint is equidistant from both endpoints. Equidistant is a fancy name for saying equal distance. Below, you can see I've included the same example from earlier. We've already done this work, and we found out that x equals 5. The question that we're trying to ask and answer is H the midpoint of FS? And we need to explain that reasoning. Well, to find out if H is the midpoint of Fs, we have to conclude that FH is equal to HS, where H would lie right in the middle of this line segment. To do so, we need to plug in our X value into the expressions of FH and into the expression of HS. After plugging in our X value into both expressions, we find out that FH has a linear measure of 11 and HS has a linear measure of 13. Does that make H the midpoint of FS? Well, is H equidistant to F and S? Our answer is no. We can now conclude that H is not the midpoint because it is not equidistant to both endpoints. After speaking about linear measure, line segments, congruence, and midpoints, we're going to talk a little bit about triangles. Well, a triangle is a three-sided closed shape made up of three line segments. Remember, every line segment has a linear measure. Below, I've included our first triangle. It is triangle ABC, where we have line segment AB, BC, and CA. Right now, we don't have any linear measures to them, but in reality, we know that every line segment has some sort of measure. Classifying triangles by sides. We know that a triangle is made up of three line segments. Well, there are three types of triangles, and they're all based off of their side measures. We have scalene, isosceles, and equilateral. The question is, what makes these types of triangles special in their own ways? Well, I've included tick marks to all three of these diagrams to try to represent congruent segments. As you can see, a scalene triangle has line segment with one tick mark, a line segment with two tick marks, and a line segment with three tick marks. Well, none of these tick marks match, so therefore we can conclude that every line segment of a scalene triangle has different measures. Now let's take a look at an isosceles triangle. In the isosceles triangle, we have tick marks on two line segments. Both of these line segments have one tick mark. Well, that means they both have the same linear measure. Well, an isosceles triangle is a triangle that has two congruent sides. The third type of triangle would be an equilateral triangle. Looking at this, we see that all three sides have two tick marks. Well, those tick marks, again, represent that all three sides have the same linear measure. Well, in the word equilateral, you see equal. Well, an equilateral triangle has three congruent sides.